Few engineers today consider the installation of a steam boiler without seriously considering a deaerator as well. It's just good engineering practice.
First of all, a lot of people don't realize there's air and water. Of course, most of you do, but every once in a while you have somebody that can't really believe there's air and water. And one of the best ways to illustrate it is by asking them, well, how do fish live then if there isn't air and water? Because they get the air out of the water somehow. Don't ask me how they do it. But anyway, air in water is a very destructive force.
Oxygen corrodes ferrous metal. Oxygen removal is a primary reason for deaerating water. Jim Williams explains that and other reasons for deaerating.
First of all, why deaerate can be answered, but why deaerate? Oxygen removal, that's number one, of course. Carbon dioxide removal, of course, they kind of go hand in hand, and I'll show you why that's also important. Basis for improved operation, and that means that by putting in a deaerator, you intend to upgrade your entire system. Maybe you'll put in modulating feed water, better pumps, recover more condensate, which ties in with energy savings, because sometimes your best energy savings in the entire plant is the installation of a deaerator, because it does save the energy. Also improved heat transfer, and I know a lot of you that are in heat exchangers know that how much non-condensable gases in a heating medium like a heat exchanger and so forth will impede the transfer of heat, so the removal of oxygen and any non-condensables. Of course, when you say removal of oxygen, you're really saying removing the air. Of course, air happens to be 4/5 nitrogen and 1/5 oxygen. The nitrogen doesn't usually perform a problem with it, but you have to get that out too, because that's part of the air. So when we take oxygen removal, if we take out one part of oxygen, we're really taking out 4 more parts of nitrogen. When you get home, take a pan and put it on the stove and put about 1 inch of water in it. And I want you to do 2 things. Number 1 is put it on a high flame and watch it boil. Wait for it to come from cold water. And as it heats, you're going to see little bubbles form. Well, you might think those are steam bubbles. They are not steam bubbles. And as you get closer to boiling, they get more and more profuse until you hit just about boiling, and then almost magically appear. The whole bottom of the pan and the side up to the water level will just appear with bubbles right away, and they'll seem to grow on you. And then when the thing hits a boil, they'll disappear. And why do they disappear? Agitation. So we've performed 2 functions of deaeration. That's temperature and turbulence. And once you do that, you tie up the ferrous hydroxide and turn it to a ferric hydroxide. Now that happens to be rust. And so once you turn that to ferric hydroxide, you grab a little more ferrous hydroxide out of the solution. It ties up with oxygen, and the reaction continues until either the oxygen is entirely removed from the water, deaerated, or the metal has been totally dissolved. It's a natural function. It's something that will happen. So what I'm basically saying here is, if you have air in a vessel, in a piping system and condensing and so forth, these will take place. Can't stop it. So what do? You deaerate. First of all, I mentioned that bringing the water to a boil removes the oxygen. It removes a great deal of the oxygen, but not all of it. Because if it was that simple, you wouldn't need deaerators. It says water simply cannot contain dissolved gases at saturation temperature. In other words, you can't put air into water at 212, but it doesn't necessarily mean it's going to come out all by itself either. Saturation conditions alone do not assure complete gas removal. Temperature, we talked about heating the water up to temperature, has to be corresponding to the pressure inside the vessel. If you're using a pressurized deaerator and it's running at 200, running at 5 pounds pressure, it should be 227 degrees. If you're running at 15 pounds, it'd be 250, or a few degrees less, because there's a radiation loss and there's other factors that take place. But if you have an atmospheric deaerator, for instance, is running at 280 degrees, you're not deaerating, you're actually literally dissolving your vessel, because between 180 and 200 degrees is where the water is most reactive, and if you don't get rid of the oxygen real quick at that temperature, you're going to lose your vessel. That's why so many of the atmospheric deaerators are going out. Don't see a pressurized. We've never lost a pressurized deaerator due to corrosion or any other reason for that matter. But we continue to replace not just our atmospherics, but Schaub's and domestics and some of the others that made Kiwani deaerators, because the vessels are simply not run properly. If they're run at 212, they won't corrode, but they run them at lower temperature. Okay, so now we got turbulence. We talked about turbulence a little while ago. Once you get the oxygen ready to go, you got to shake it out. Now, the thinner the film, in other words, if you had that inch of water into a pie pan, which only a quarter of an inch or an eighth of an inch of water there, the oxygen would have less distance to travel, and so it would get out of there easier. And almost all, if not all of your deaerators use a thin film technique to get the oxygen out. And then, of course, time is a factor. And if you have a good imagination, you take a, and we'll talk about it in a second because I'm going to show you how our jet spray works. But the jet spray sprays water in, hits a pan, goes through a thing, hits another nozzle, exploded out, and hits the water level. Now, once it's done that, it's through. You can't get any more oxygen out of it with a jet spray. It's all done. That's why they're kind of critical. There are several applications they shouldn't be used for, and we'll talk about that too. But the point I'm trying to make is, how much time are you talking about? Second and a half, 2 seconds? And of course, once all this has taken place, if you don't get rid of the air out of the system by venting some of it or all of it, all the gases to atmosphere, then you don't do anything. I've had a lot of cases where a guy will call me up, he says, I got 5 pounds on the deaerator, 180 degrees, and I can't understand it. It's supposed to be 227. I said, well, was your vent valve open? What vent valve? Oh, okay. Just open your vent valve and call me back in about an hour if they don't get up to temperature, and never hear from them again. But you have to vent the steam out, and a lot of people forget that, unfortunately. And then just the last thing I wanted to point out is a fact that we're seeing more of, that few engineers today consider the installation of a steam boiler without seriously considering a deaerator as well.